4, but before I start number 4, I should record correction for number 3. So the correct answer for number 3, whoops, uh-oh. No, I just hit the screen off. Come on, come back. There we go. Is this still recording? Let's see. Yes. Alright, correction number 3. Answer should have been 0.0698, so 7 meters per second rather than this. So,
that's wrong.
Yes, we've established that we do not know how to use our calculators in this classroom.
Is the formula wrong?
No, the form is not wrong. The user is wrong. The user is wrong.
User wrong.
Yes, user wrong. User error. All right.
It's pretty much the same actually. 0.07.
Big difference.
Oh, it's quite different, like a factor of 10. Now, moving on with our lives. Number 4. So you got this table here, and if you look at this, how many forces are acting on this table? How many forces on this table?
Weight.
Well, there's definitely a weight.
And then the earth.
There's definitely a weight. And then what else?
And the air.
There's these 2 legs providing up support. Yeah?
It's A and B.
It's called A and B on the graph. Can you see it there? Yeah. Right. First piece of business is to write in all the distances. So this distance here is 0.3. How long is this whole meter stick? It's not a meter stick. How long is the whole thing? It's so the next one will be 0.3 plus 0.9. So 1.2 to this next one here. Now don't be confused. I'm measuring all my distances from the start here, okay? So it's 0.3 to there. It's 1.2 to the whole thing. Or if you want,
1.8.
1.2 is 1.2.
1.2 from here to here. Yes?
It's 1.8.
Yeah.
1.3 to there.
Yeah.
And then to the whole length to here,
Yeah.
to S, is 1.2. The W will always be in the middle. So the total length is 0.3 plus 0.9 plus 0.6. So this is 1.8 meters long.
Yes. This is 0.9.
So that'll be 0.9. Okay? To the middle. It's half the total length. Alright, so we want to and we know the W because it's 5.5. So 5.5 times 9.81. So the weight is 53.95. So 53.96 newtons. 53.96 newtons is the weight. And you know what? To make our lives easier and more pain-free, we'll use derived to solve the equations to save time. Okay.
So what is it given?
Where's what given? The weight?
Yeah.
It's given mass of 5.5 at the start.
Okay.
Now, here, this table is not moving. So that means the total force going up, what's the total up force here? R plus S should equal 53.96 newtons. But this is not enough because there's 2 unknowns here. Okay? So what we have to do next is look at the turning force. Now, let's start here as the turning point. Is the oar clockwise or anti-clockwise? Anti-clockwise. This one? Clockwise. And this one? Yes. Like a clock. And then this one here,
Did they mention
anti-clockwise. What's it, Andy?
Did they mention that is the turning point? Or
No.
we just
Now
make
listen
it-
carefully. Listen carefully. You can choose anywhere to be the turning point and you will all get the same answer.
Won't R be easier to prove?
It would be
Easier.
easier in the so far as it'll give you the S quicker. However, the distances are easier to calculate. So if you use OR, then you'll have to start changing your distances. And just
Because they gave us the distance from R to S in the question.
yes, but they didn't give us the distance from OR to W.
Yeah, we just did say.
But I know, but I just said 30 seconds ago you can use any turning point, okay? When I did this with the intake 1 students, I used OR. I feel like this morning using the starting point, alright? Maybe next year I'll use S. Who knows, alright? But today I'm going to use that point. If you want to use something else, I have no problem with this, alright? Now, the OR is clockwise. Sorry, MB, you're confusing me. The OR is anti-clockwise. So what you can say is the anti-clockwise equals the clockwise. So how much is this anti-clockwise turning force here? Remember the formula? What is it? It's the distance multiply the force. So 0.3 R plus 1.2 S should equal 0.9 times 53.96. This is the anti-clockwise plus the anti-clockwise must equal the clockwise. Does it make sense where they came from? Is that okay, Abdal? You okay? It makes sense? The formula, the turning force is equal to the force multiplied the distance. Remember, it's called moment? Yeah? Oh, whatever. Right, now, that number here is actually equal to, if you multiply it out, 48.56 newtons. Now, how many equations do we have here? 2. And how many unknowns? 2. How many methods do you have to solve this from maths class? You have elimination, substitution, and matrix. Use whatever you want. Whatever, I don't care. But to save time, I'm just going to use derive. So can you read these back to me? I'll just type them in. So the first one, what is it?
R plus S.
Yep.
53.96.
Thank you. Next one?
0.3 R
Yep.
Plus 1.
1.2
Plus
1.2s.
equal to 48.56.
For sure?
yes.
Alright. Solve system 2 and that one and solve and simplify, approximate. So you get R is 17.99. So basically R is 18 newtons. And then S is 35.97. 35.97 if you like. Or if you want to round that off, it would round off to 1 decimal place would actually round it off to 36. 36 newtons. I'm not going to solve it because that's a maths thing, which you should be very comfortable solving 2-degree system. Yep, okay.